Today, let us look at equations reducible to a pair of linear equations in two variables. Let us look at this pair of linear equations. Do you notice something interesting in the first pair of linear equations? Yes, the variables x and y are present but in the denominators. Let us assume 1 upon x as p and 1 upon y as q. Now we can rewrite these equations as 2p plus 3q equals 13 and 5p minus 4q equals minus 2. Now this pair of linear equations can be solved for p and q. Let us look at the second pair of equations. Once again, the variables are present but in a different form. So we have x minus 1 in both the equations and y minus 2 in both the equations. Let us assume 1 upon x minus 1 equals p and 1 upon y minus 2 equals q. Rewriting these equations in terms of p and q, now we can solve them for p and q. Let us look at the third pair. Once again, we can see common terms between the two equations. X minus y is one term and x plus y is another term. So we can take 1 upon x minus y equals p and 1 upon x plus y equals q. Rewriting these equations in terms of p and q, now these look familiar and can be solved for p and q. Let us look at a few problems. Solve the pair of equations. Now notice the common terms between these two equations that have the variables in them. So x plus y in the denominator is one such term and x minus y in the denominator is another term. Let us write 1 upon x plus y equals p and 1 upon x minus y equals q. Rewriting the pair of equations in terms of p and q, let us simplify them. So we get 5p plus q equals 2. Let us write q in terms of p. We get q equals 2 minus 5p. Now we are going to substitute this value of q in the other equation. Solving for p, we get p equals 1 upon 5. Substituting this value back, we can find the value of q. So we get q equals 1. Now recall that we wanted to solve for x and y. So let us write 1 upon x plus y equals 1 upon 5 and 1 upon x minus y equals 1. Let us cross multiply and add the two equations to eliminate the variable y. We are using the elimination method here. Solving, we get x equals 3. Now we can substitute this value of x in either of the two equations and find y equals 2. Let us look at another problem. Ritu can row downstream 20 kilometers in 2 hours and upstream 4 kilometers in 2 hours. Find her speed of rowing in still water and the speed of the current. So Ritu is rowing downstream, which means in the direction of the water current. So writing distance equals speed times time, we get 20 equals speed multiplied by 2. Now let us say that Ritu can row at v kilometers per hour and let us say that the water is flowing at a speed of u kilometers per hour. So the speed is going to get added because the water current is helping Ritu in her direction of rowing. So we get 20 equals v plus u times 2. Similarly, while rowing upstream, Ritu is rowing against the current. So her speed is going to be reduced. So this time, distance equals speed multiplied by time, we get 4 equals speed times 2. And now, since her speed is going to be reduced, we would write v minus u as her speed. Now we have a pair of linear equations in two variables, v and u. Let us solve for v and u. We can easily eliminate one of the variables by adding these two equations. So let us use the elimination method and get v equals 6. Substituting this value of v in one of the equations, we get u equals 4. Let us write down their units and we get u equals 4 km per hour and v equals 6 km per hour. So the speed of the current is 4 km per hour and Ritu's speed of rowing is 6 km per hour. Let us look at another problem. 2 women and 5 men can together finish an embroidery work in 4 days, while 3 women and 6 men can finish it in 3 days. Find the time taken by 1 woman alone to finish the work and also that taken by 1 man alone. While this problem might look complicated, it is very similar to the last problem. So the way we wrote distance equals speed multiplied by time, here we could write work done equals speed of work times time taken. So here we are talking about an embroidery work. We would write one embroidery work equals speed of work times 4 days. Now let us say speed of work of one woman is W work per day and speed of work of one man is M work per day. So now we could write one embroidery work equals 2W plus 5M times 4 days. But in the question, we have to find the time taken by one woman to finish the work. We don't have to find the speed of work of one woman. Now the speed can also be written as one work divided by number of days. Or let us write it as 1 upon x, where x is the number of days. Similarly, let us write m equal to 1 upon y, where y is the number of days taken by a man to finish one work. So we can rewrite our equation as 1 equals 2 upon x plus 5 upon y times 4, where x is the number of days taken by one woman to complete one embroidery work, and y is the number of days taken by one man to complete one embroidery work. This gives us one equation. Now let us look at the second equation. So we have 3 women and 6 men and they're finishing one embroidery work in 3 days. So writing work equals speed times number of days, we can write 1 equals 3 upon x plus 6 upon y times 3. Now we have our variables x and y, but they are appearing in the denominator. So let us take 1 upon x equals u and 1 upon y equals v. Rewriting these two equations, we see that the coefficients for both the variables are different. So let us try to equate the coefficients for the variable u and subtract one equation from the other. We are using the elimination method here. So we get v equals 1 upon 36. Substituting this value of v, we can find that u equals 1 upon 18. But we had to find x and y. So let us write v equals 1 upon y and u equals 1 by x. We get y as 36 days and x as 18 days.